Hey physicists, so today we are going to look at this cart and pulley lab. It is also called a modified Atwood machine, but we're going to use this to really look at Newton's second law of motion. Okay, so today you can see that the research question is, how does the mass of a cart affect the time and thus the acceleration of the system? So really we're looking at how does the mass affect the overall acceleration. So we're comparing mass and acceleration today. So you can see on this video, I have a cart and I have a frictionless surface, or as frictionless as I can. So I'm not going to look at friction today. I have a track, and then I have a string that is looped around here and goes over a pulley. So then it can change directions, and we'll put this hanging mass on the end of the string to create a force to pull that cart across the track. Okay, so right now I don't have any hanging mass on here, so I'm going to change the hanging mass, and let's say I put about 80 grams on here. Okay, then I have the mass of the system. So I have the cart right here, and I have some weights, and so you can load the weights up onto the cart. So let's say that I'm going to put about 500 grams total for my system. Okay, so when I refer to a system, I have this whole thing is now my system. So the cart, the string, and then this hanging mass right here. Okay, so when I push play, you can see it go, and I have the person cut the string and the cart starts to move. So it starts to accelerate. All right, and you can see then all of a sudden it hits the edge of the pulley here and bounces back. Okay? So we are interested in just that first part of the motion. If I take it back a little bit, and I'm going to push play again. Now notice that the hanging mass is falling, and then all of a sudden, boom, when I stop it right here, this string becomes looser. All right, so I have no tension in this string anymore. No force. So think to yourself, all right, self, if I have no net force on the cart, what will the acceleration be? All right, so I don't want to look at that part. I want to look just at this beginning part. So this hanging mass creates a force down. So gravity is pulling down, and then the tension is it changes as it goes around the pulley. So now I have the tension in the string, okay? So my force is going in that direction. And when I push play, you can see that the cart starts to move and it accelerates here and again up until that point right there, okay? So I wanna look at my displacement, how far it's moving, all right? And then also I wanna compare the times, okay, here. So I have my meter stick set up so that the 0 is at the start of the cart. I have my stopwatch set up here, and I'm going to 0 the stopwatch. Once I cut the string, so you see that the string is being cut right here, all right? And my cart begins to accelerate, begins to move. So I'll reset my stopwatch. Okay? Now, by comparing the displacement, how far it goes, and the time, we are going to figure out the acceleration, how it accelerated, all right? Now, I can change this mass. So I'm going to change it up to 700 grams, okay, and load it up. So now notice that one of the masses now has been put on the system. So this whole system, now the system mass has changed. And we're going to do the same thing, see what happens. So I'm interested in the relationship between how the mass changes on that and how that changes the acceleration. So notice I'm keeping the force constant on this, okay? So as always, please let me know what questions or concerns that you have. So use your lab sheet to complete the rest of this lab. All right, thanks for watching.